Load of the beam of uniform cross section shown in figure. So this is your diagram. You have a propped cantilever beam. One end is fixed and you have a prop here. This is the load, which is W, and this is W by 2. Two loads are acting in this given data. Okay, from this given data, can you say that where you will be having the first plastic hinge or first collapse? Between span A and C or span C and D? See, you have two loads. Between span A and B you have one load, and between C and D you have another load. If you keep on adding the load, that is W, you imagine that I am adding W as 1 kilonewton. 2 kilonewton. I am keep on adding this load. If I add W as 1, this will be 1 by 2. It will be 0.5. If I am adding the loads, which span will get collapsed? Either AC or CD. Let us derive and find the solution. So let us take the two span, that is A and C, which is the first span. The second span is C and D. The load is W here, and between C and D is W by 2. Note that if 100 Newton is applied at AC, so what will be the Newton here? 50 Newton only. So which is going to break first? You are going to find. For finding that, what theorem you can use is principle of virtual work. So this is the concept or principle you are using. So what does this principle says that? External work done equal to internal work done. This is your equation. External work done equals internal work done. Okay, what is work done? Load into distance. So this is your formula. For whole problem, simple to concept is known, you can solve any number of problems. Okay, now you are going to solve this. You take span C and D first. So this is span C and D. So first you are taking C and D. This is C and D. This is the point where you will be having hinge at C and D. See, C and D span is a cantilever beam. So you omit this, you will be having a cantilever only. You omit A and C, only you just look into the span C and D. At one end it is being supported and other end is free. Hence it is can be called as a cantilever. So for a cantilever, you will be having a hinge at the support. So you have a hinge at the point C. Note that for a cantilever beam, you have a load here. For a cantilever beam, you will be not having plastic hinge at the load point. You will be having only at the support. For a simply supported beam, at the load, find the difference. For a fixed beam, both the fixed end as well as the load for all the three cases. So you take it down as a note and you remember for all your problems. Since this is a cantilever beam, you have a plastic hinge at the support, which is there MP here. Now you have a triangle. Since if you catch this support and if you keep on add the load, what will happen? This beam will deflect up to this much, and at certain point this will get broken at the support. Okay, now how to find this distance? The same formula which you used for previous problem. How to find the triangle? The height of the triangle. Take this as a triangle. So what is the base of this? Base is L by 3. So this is known. How to find the height? You can imagine this as what? Theta, and how you can find the height here? Tan theta. You can use the same concept, tan theta. You take this as delta divided by tan theta equal to delta divided by opposite by adjacent. What is adjacent here? L by 3. So delta divided by L by 3 will be your answer. Since theta is very small, you can remove tan. Theta equal to delta divided by L by 3. Find your external work done. What is external work done? Load into distance. So what is your load? W by 2. So this is your answer. And what is the internal work done? Internal work done is you have to multiply plastic hinge into theta. So what is your plastic hinge? Which is MP into theta. Now you equate these two, you can find W. Write down this step as external work done. External work done is load into deflection. Right now your load is W by 2 and deflection is theta L by 3. Now if you multiply, you will be getting WL by 6 theta. Your internal work done will be MP into theta, and if you equate both the thing, WL by 6 into theta equals MP theta. Now what do you need? You need W. W is what? Collapse load. So if you need W, take the rest of the things outside. So what will be your answer? Keep W here, take rest of the things outside. 6 MP by L. You will be getting WU as 6 MP by L. Let us find for span AC. So what is span AC? This is your interior span. You have found mechanism for case 1, that is span C to D. Now you have to find for span A to C. Okay, for finding this, you have a fixed end here. You will be having a MP here. This is first MP, and since you have a load and a prop here, so you have load and prop. Wherever you have load, you will be having a hinge here. That is second MP. So this is your mechanism. And since you have a prop, what will happen? If load is acting down, so you will be having an upward motion for this support, for this span, yes or no? If I am trying to push this down, what will happen? This span will get uplifted. Hence, it is drawn in this manner. So this is the mechanism. You will be having a triangle here, and at this portion, you will be having a upward deflection, not downward deflection. If you keep on adding the load at the support, at the load, you will be having the negative impact. Whatever deflection is here, this will be reversed here. Okay. How to find the external work done? So your formula is simple. External work done equal to internal work done. What is work done? Load into distance. What is your load here? W. What is the distance here? Delta. So how to find delta? Apply tan theta concept. Since the span is L by 2 and L by 2, you have the load exactly at the center. You will be having same theta. Theta and theta will be same. What is delta here? Theta L divided by 2. That is your delta. Okay. Now what is your external work done? Load is W into theta L by 2. Okay. Now this is for the first load. What about the second load? You have the second load here. For this load, you will be having this negative deflection. So your load is W by 2 and your deflection will be what? What is the base? L by 3. Now your triangle will be delta equal to theta L by 3. That will be your answer. So your work done will be what? W by 2 into L by 3. Yes, this is your external work done. Can you see the same answer here? This is your work done. See, note that you have to subtract. This is negative. This is why this is negative? Why minus W by 2 into L theta by 3 is negative. If you apply load at this span, the deflection will be in opposite direction. When it is collapsing between the span C and A, this will go into reverse direction. That is why you are subtracting here. So your answer will be WL by 3 theta. This will be your answer. Now, what will be your internal work done? How many plastic hinges will be here? MP is first plastic hinge, and so what will be its rotation? Theta plus you have MP here. What is this rotation? 2 theta. That's all. MP theta plus MP 2 theta. That will be your internal work done. Totally 3 MP theta. Now you equate that. You will be finding W. W equal to 9 MP by L. You are going to equate WL by 3 theta equal to 3 MP theta. Now at which load you will be getting collapse? You got two answer, no? Which span will get collapse? This is 9 MP by L and the previous answer was 6 MP by L. Okay. So what do you mean by that? See, take MP as a constant. Take MP as 10. Now you substitute here. 9 into 10. Take L as also 10. Take your span as also 10. So it will get cancelled. Your collapse load will be 9 kilonewton for the span A and C. What about the span C and D? What was your answer? 6. So here 6 and 6 will be your answer. Okay. At which load first collapse will occur? 6. When you keep on adding the load, 1 kilonewton, 2 kilonewton like that, at 6 kilonewton which will break first? The span C and D will break first, then your second span will break. Now, okay, after learning this problem, what is your understanding is a civil engineer can have number of span. See, your college building have, this is span 1 and span 2, span 3. You have 3 span here, yes or no? You are having UDL. All the loads are UDL or point load? All are UDL. If you know this concept, you can say that, imagine that you are having severe wind blow. Then you are having a severe earthquake. As a civil engineer, you can say that which beam will break first. Then what will be the second failure? How this will break? Can you recognize the previous cases? A building is collapsing step by step. So I have shown you that no. If you know this concept, you can say that which span will break first, at what load it will break, and what will be next. Like that you can find the collapse load. Determine the collapse load for the continuous beam having a uniform cross section as shown in figure. Now you got two spans here and load is given as 2W and 3W. For the 2W load, which is having a span of AB, it is located at the center, that is L by 2 and L by 2, and second load which is acting at L by 3 and it is acting at 1/3 of the span. These drawings are known as mechanism. Since you have two span, understand that how many spans are there, that much of mechanism should be written by you. If you have 3 number of span, how many mechanism will be there? 3 span, you should have 3 mechanism. You have 2 span, span AB and BC. Hence you will be having 2 number of mechanism. Now let us take the span A and B. If I am taking only the span, where are the position you will be having hinges? You have a load, hence you will be having a hinge which is MP, and since you have a negative moment here, will you have negative moment or not? At the intermediate hinges you will be having negative moment, hence you will be having a hinge here, that is 2 hinges. The theta will be same. Why? Because the load is acting at which point? Exactly at the center. Hence you will be having both the thetas will be same. This is your first mechanism. You have two number of plastic movement here. What is your external work done? Load into distance. What is the load here? 2W. What is the distance? Theta L by 2. That's all. You will be getting WU L theta. Are you getting this answer? Yes. Then what about internal work done? How many MPs are here? 2 MP, and for this MP into 2 theta, and for this MP into theta. How many MP theta? 3 MP theta is your internal work done. Now you equate internal and external work done, you will be getting the W. What is the answer? You equate these two, you will be getting W. WU is ultimate load. So theta and theta will get cancelled. WU equal to 3 MP by L. This is your first mechanism. If you have any other support after this, this will prevent the lifting. For the previous case, do you have any other support apart from that? See, this was your span, and if this span tries to lift, this support will not allow. You have a hinge here, this will not allow to lift, it will drag down. Whereas in the previous case, so you check the diagram, you are not having any hinge or the supporting point. For the span BC, this will be your triangle. Wherever you have load, at that point you will be having a hinge, and at B you have negative moment, one hinge is there, and at C, since this is a hinged end, you don't have any negative moment. That is, the moment is 0 here. You will be not having any MP. Okay. Now the MPs are taken. Note that for previous case and this case, your theta is not same here. Why? Because the load was acting at the center for the previous span. Also for the previous cases, whatever problem you solved, the load was exactly acting at the center. If the load is not acting at the center, you will be having this as theta 1 and this as theta. You will be having different thetas. How you can find the distance? How you can find the distance here? What is your known formula? Tan theta. What is tan theta? Opposite by adjacent. So tan theta 1. If you put tan theta 1, so what will be your opposite side? Delta divided by L by 3. You keep it one side. And let us take theta. Let us take this triangle. If I am taking this triangle, how to find delta? Tan theta equal to delta divided by 2L by 3. Can you equate these two answers? Both are same, yes or no? Whenever you take this triangle and this, the height will be same. If you equate that, you will be getting theta 1 equal to some theta. Both are equal. First delta, what is your answer? Theta 1 L by 3, and second triangle will be 2 by 3 L theta. Are you getting that? Both will be same. Theta 1 equal to 2 theta. If you equate these two, you will be getting theta 1 equal to 2 theta. You will be getting the mechanism as, if you have theta 1, you have to add theta 1 plus theta. Now, instead of theta 1, can you substitute 2 theta? Yes. So, this will become what? So, MP 3 theta. Okay. Now, what is your external work done? What is the load? 3W. What is the distance? You can take L theta 1 by 3. What is theta 1? Substitute it as 2 theta. You will be getting external work done. What is your answer? 2W L theta. Yes, you will be getting this answer. Now, what is your internal work done? How many MPs are here? 2 MP MP theta 1 plus MP theta plus theta 1. You have to substitute theta 1 as what? 2 theta. You will be getting one internal work done. Load is 3W and distance is 2 by 3 L theta. Then you substitute the internal work done.